Good afternoon students, I am Ripin Patel and I welcome you to study concepts of maths with me. The very first chapter in your textbook or syllabus is angle and its measurement. So the word angle we have been using since many years. In fact, I'll say the word angle was introduced to our syllabus in 5th standard. But still, let's recall few terms and few definitions with reference to angle. So to begin with, let's define angle. How will we define angle? If two rays are seen diverging from a point, if two rays are seen emerging and then diverging from that point, then the region or the space between these two rays is termed as angle. In fact, some of mathematicians or people define it as the rotation. There is one arm and the amount of rotation which is provided to form that angle or to get that region is termed as angle. We'll deal with measure of these angles in detail in coming topics, but still for now I'll say angle is measured in degrees, right? Angle is measured in degrees, and we have seen how to draw an angle of given measure of 60 degree or 90 degree and so on. Okay, now a few more terms like vertex. The point from where these two rays emerge is known as vertex, and these two rays we say are arms of the angle. Interior of the angle. When do we say a point in a plane lies in the interior of the angle? If the point lies between these two arms, if the point lies between the two arms of an angle, then we say the point lies in interior. And if it does not lies somewhere else in plane, we say it lies in exterior of the angle, right? Moving next to types of angles or angles of different measure. Straight angle, if you remember, if the two arms are in opposite direction, the two arms are exactly in opposite direction, then we say the angle formed is known as straight angle, and the degree measure of it is 180 degree. Measure of straight angle is 180 degree. Next comes full circle angle. Full circle angle is what? Starting from one of the arms, if you give it a full circle rotation, if you give it full circle rotation, then we say the angle formed is full circle angle, and its measure is 360 degree, right? Or we can also say two straight angles together make one full circle angle. Right angle. When one of the arms is perpendicular to the second, if one of the arms is perpendicular to the other arm, then the angle formed we say is right angle, and its measure is 90 degree. Right? Then acute angle. If rotation given to one of the arms is lesser than that is given in right angle, then we say the angle is acute angle. Or we can also say if measure of an angle is lesser than 90 degree, that is of right angle, then angle is known as acute angle. Obtuse angle. Once again, if the rotation given to one of the arms is more than that in right angle, right? If the rotation given to one of the arms is more than that in right angle, then we say angle is obtuse angle. Its measure is greater than 90 degree and less than 180 degree. Reflex angle. If rotation given to one of the arms is more than that in straight angle, rotation is more than that in straight angle, then the angle formed is known as reflex angle. Then few definitions for pair of angles. You would have heard of complementary angles. When do we say that the two angles are complementary? If sum of measure of two angles, is equal to 90 degree, then we say the two angles are complementary. In fact, acute angles of a right angle triangle, if you remember, are always complementary, right? So complementary angles are what? angles, sum of measures of which is 90 degree are known as complementary angles. One more word, supplementary angles. When do we say that two angles are supplementary? A similar definition. If sum of measures of two angles is equal to 180 degree, if sum of measures of two angles is equal to 180 degree, then we say the two angles are supplementary, right? Now moving to next, in junior classes when we were asked to draw an angle of measure 60 degree, what we used to do, we simply used to draw a ray, and then using a protector we used to draw a terminal arm or another ray which would represent 60 degree. But now we will need to measure or to show angles in standard position. Angles in standard position. So whenever this word standard position is used, actually it is referred to coordinate system. Coordinate axis, x-axis, y-axis, origin and so on. So the term standard position is referred to coordinate system. So when do we say that angle is drawn in a standard position? If vertex of an angle is at origin and positive direction of x-axis is taken as initial arm, and from there we give rotation to show that or to mark that angle, then we say that angle is drawn in standard position. For example, here you can see 30 degree is shown in standard position. So initial arm is positive direction of x-axis, vertex of the angle is at origin, and it is rotated in anti-clockwise sense till it coincides with 30 degree measure, right? So this is 30 degree in standard position. Similarly, we can show 45 degree in standard position, 90 degree in standard position, 135 degree in standard position, 180 degree in standard position. Even you can show reflex angles. See, 225 degree, that's reflex angle of measure 225 degree in standard position. 315 degree was another angle, right? Now here is an important one. Till junior classes we have seen angles of measure up to 360 degree, but in standard position we can show the angles or draw the angles with measure greater than 360 degree. See, this is one of the examples. 405 degree, one full rotation and then 45 degree extra. So this is angle of measure 405 degree. Another one, 540 degree, one full rotation and then another 180 degree. 720 degree, two full rotations give us an angle of measure 70 degree. So this is what we say is angles in standard position. Now moving to next, an important word, directed angles. Repeat, directed angles. We have seen many physical quantities which have directional sense. The best example is force. Force cannot be completely described unless until we mention its direction, right? But have you ever thought that even angles have directional sense? Yes, even angles have directional sense. Let's see what a directed angle means. To understand directed angle, consider the ray OA. Consider the ray OA. Rotate it about the point O till it coincides with OB vector. Rotate the arm or ray OA vector, OA, till in anti-clockwise sense, till it coincides with OB vector as shown in the figure. Then this angle formed is known as directed angle AOB, right, as shown by the arrow. So directed angle AOB is one. Arm OA was rotated till it coincides with OB, right? So that is directed angle AOB. How to name them? There's a slight difference in naming. Angle AOB, directed angle AOB is shown as the sign of angle and an arrow on it. So that is directed angle AOB. Or there's another notation also. We can show them as ordered pair of OA vector and OB vector. So OA vector here represents what? Initial arm, and OB vector represents what? Terminal arm of the angle. Right? Now let's see how angle BOA, directed angle BOA, is different from directed angle AOB. To obtain directed angle BOA, what you need to do is you have to rotate OB vector. You have to rotate OB vector till it coincides with OA vector. So rotation provided here, rotation provided in this case is opposite to that we have done in provided in the first one, directed angle AOB, right? So though their measures are equal, but they have opposite directions. AOB was directed from OA vector to OB vector, whereas OBOA is directed from OB vector to OA vector, right? So I hope you have got the concept of directed angles. Let's conclude. So what we can say is direction of directed angle is always from initial arm to final arm. I'll repeat. Direction of directed angle is from initial arm to final arm. Then, though directed angle AOB and directed angle BOA are equal in magnitude, but since they are opposite in direction, I'll say directed angle AOB is not equal to directed angle BOA. Though in previous standards we used to say angle AOB or angle BOA are one and same thing. But when it comes to directed angle AOB is different from directed angle BOA. Now, one very important concept. In directed angle AOB, arm OA was rotated in anti-clockwise sense. Arm OA was rotated in anti-clockwise sense. So its measure will say by convention is positive. If angles are measured in anti-clockwise sense, we say it is positive. Whereas in angle BOA, arm OB was rotated in clockwise sense. So I'll say measure of angle BOA is negative. Right? So whatever angles are measured in anti-clockwise direction, I'll say its measure is positive. If angle is measured in clockwise direction, clockwise sense, I'll say its measure is negative. Right?
Choose the right kindergarten, a right bag, and matching bottle to go with. The right school, the right friends. Choose the right subjects and score well. Be an expert in all. The right teacher, and make sure that they like you. Choose the right timing, the right bus, and take a cab if getting late. The right train, and don't stand near the gates. Mind the pockets. Better get into ladies' compartment. And make sure your mustache hasn't started coming. Choose the right study time and forget games. IPL, IHL, rock and metal, guitar, axe. The right group, and be a model to your brother. Seriously. Choose the right syllabus, the right test paper. Keep guessing questions for exams. Choose the right branch, the right college, the right stream. Choose the right career. Lucky to have a father's business to take care of and a father to allow that. The right counselor, the right form, and make sure the project is submitted on time. Choose the right website and rely on your friends for more information. Oblivious of the sites they have been to, there is no end to your woes. Getting better with every step you climb up the ladder. The summer vacation shorter, the bucket list bigger, the night darker, the books heavier. The only light you have is your friends ahead of you. Probably he is right. Ever thought how he got the direction? No more spending your energy and money on coaching classes. No more missing classes for rain, rally, and nonsense. Get your interest back in subjects through our creative ways of teaching. Doubts, concepts, applications, all explained through one vibrant animation. Subjects covered by multiple teachers with repeat telecasts. Special programs only for basic foundation and paper analysis. Personality development, career counseling, admissions, hobbies, all covered. A new approach to study with long-term perspective. So sit back comfortably in your homes and watch Study Spectrum TV channel.
So students, few more definition with reference to angles in standard position. The first one, coterminal angles. When we refer to angle in standard position, initial arm of every angle is same, and that is positive direction of x-axis. And vertex is same, that is origin. But if you consider two angles, suppose 60 degree and then 420 degree, terminal arm of 60 degree and 420 degree is also same. So if you consider the two angles 60 degree and 420 degree, the initial arms are the same. Initial arm of every angle in standard position is same, but their terminal arms are also same. Such angles are known as coterminal angles, and this is an important term, coterminal angles. Any two angles, difference of their measures if is multiple of 360 degree, then such angles are known as coterminal angles. The simplest example is 60 degree, 420 degree, 780 degree. All these have the differences as multiple of 360 degree. So such angles are known as coterminal angles. Later on in trigonometry we will see, when we will introduce trigonometric functions, we will see value of trigonometric functions for coterminal angles is same. That is, find sine 60 or measure sine 420 degree or measure sine 780 degree is one and same. So coterminal angles, this is an important definition. When do we say the two angles are coterminal? When difference of degree measures of two angles in standard position is multiple of 360 degree, then we say the two angles are coterminal angles. Now coming to next, angles in quadrant. Angles in quadrant. Consider an angle 75 degree. Its initial arm as usual will be what? Positive direction of x-axis. Now what is or where does the terminal arm of 75 degree falls? See here, terminal arm of 70 degree falls in first quadrant. So I will say 75 degree lies in first quadrant. Consider another example, 132 degree. Initial arm once again is same, positive direction of x-axis. Now, where does terminal arm, or in which quadrant does the terminal arm of 132 degree falls? It falls in second quadrant. So I'll say 132 degree lies in second quadrant. Right? 330 degree angle of measure 330 degree. Initial arm once again is same, positive direction of x-axis. Now question is, where does the terminal arm lies? The terminal arm of 330 degree lies in fourth quadrant, right? Terminal arm of 330 degree lies in fourth quadrant. So I'll say 330 degree lies in fourth quadrant. So let's conclude. Angles measuring just more than 0 degree and just less than 90 degree lie in first quadrant. Above 90 and less than 180 lies in second quadrant. 180 to 270 lies in third quadrant. 270 to 360 lies in fourth quadrant. Once again, 360 to 450 lies in first quadrant again. 450 to 540 lies in second quadrant. 540 to 630 lies in third quadrant, and so on. Right? Then quadrantal angles. If terminal arm coincides with one of the coordinate axis, then the angle formed we say is quadrantal angle. For an example, 90 degree, terminal arm coincides with positive direction of y-axis, it's a quadrantal angle. 270 degree. Terminal arm coincides with negative direction of y-axis, so it's a quadrantal angle. 540 degree. Terminal arm coincides with negative direction of x-axis, so that's a quadrantal angle, right? Okay, so enough of basic definitions. All these we have studied till 10th standard. Now we'll begin with system of angle measurement. Like we have seen in physics, measurement of various physical quantities had various systems, CGS units, whether CGS system was there, SI system was there, MKS units, whether MKS system was there. Similarly, we have different systems for angle measurement. And the very first of them, which we have seen since junior classes, is sexagesimal system. The first system for angle measurement, that is sexagesimal system. Angle measurement in sexagesimal system was derived from the fact that Earth takes almost 360 days to complete one revolution around Sun. I'll repeat. The concept of sexagesimal system was derived from the fact that Earth takes almost 360 degrees, not 360, we know very well, it's a 365 plus something. So almost 360 days to complete one revolution around Sun. So what convention they made, कि if a arm of any of array makes one full rotation, will claim that it has rotated by 360 degrees. I'll repeat. If an arm has rotated once fully, will claim that it has rotated by an angle of 360 degrees. So some people claim that this was the origin of sexagesimal system or degree measurement of angle, right? So what they say, like Sun, Earth, which completes one rotation in 360 days around approximately. So they say, let's say when an arm or array completely rotates or fully rotates, we'll say it has moved by 360 degrees, right? Then from there, how they proceeded, they divided that into 4 equal parts. That full circle they divided into 4 equal parts, and to one part they said as 1 degree. So that gives us degree measure of an angle, right? Now next question was, what if an angle, measure of an angle is less than 1 degree? How to measure that? So using a fact that number 60 has many multiple factors. 2 is a factor, 3 is a factor, 4 is a factor, 5 is a factor, 6 is a factor, 10 is a factor, 12, 15, 20, 30. So 60 had many factors. So what they said, it is easy to deal with number 60. So what they did, they divided the measure 1 degree into 60 equal parts, and to one part the claim was 1 minute, right? They divided 1 degree into 60 equal parts, and they said one division was 1 minute. Okay. Then they have divided minute further. So once again, they have divided minute into 60 equal parts. That small measure, 1 minute, they have divided further into 60 equal parts, and one part was measured as or read as 1 second. Right? So 1 minute was divided into 60 equal parts, and one part was read as 61 second. Right? Okay. Let's see an example to understand how degree was divided into minute or minute was converted to seconds. Suppose we have a measure of an angle as 25.35 degree as shown here. Suppose there is an angle of measure 25.35 degrees. The question is, if I don't want to deal in decimals, or the fractional part of degree measure I want to convert into minutes. So I'll read it as 25 degree plus 0.35 degrees. 25 degrees whole number part, 0.35 degrees fractional. So this fractional part, 0.35 degree, let's convert it into minutes. 1 degree is 60 minutes. 1 degree is 60 minutes. So 0.35 degrees, 0.35 into 60. 0.35 into 60, which comes to 21. So 0.35 degrees, 21 minutes. So I'll say 25 degree plus 21 minutes is measure of the angle 25.35 degree in degrees and minutes. Take another example. 37 is to 3 by 25 degrees. Suppose there's an angle of measure 37 degrees and 3 by 25 degrees. We have to convert it to degrees, minutes and seconds. So whole number here is what? 37 degrees whole number. What is fractional part? 3 by 25 degrees fractional part. So 1 degree is 60 minutes. So this 3 by 25, that is fractional part. Let's convert it into minutes. So 3 by 25 degrees is 3 by 25 into 60 minutes. Right? Let's simplify. That comes to 36 by 5 minutes. Again, in 36 by 5 minutes, 7 is whole number and 1 by 5 is fractional part. So now I'll read the measure as 37 degree, 7 minutes plus 1 by 5 minutes extra. So 1 by 5 minutes. Now I'll convert it into seconds. So 1 minute is how many seconds? 60 seconds. So 1 by 5 minutes would be how many seconds? 1 by 5 into 60. That is 12 seconds. Right? So my answer would be the measure of 37 is to 3 by 25 degrees in degrees, minutes and seconds is 37 degree, 7 minute and 12 seconds. Right? Now, like I said, there are many other systems also for measuring angles. The next system is gradient system. Use of this is very rare. Normally we don't use gradient system, but still if you check scientific calculators, you will have the third system. There are 3 modes of angular measurement: degree, gradient and radian. So this is our next system of angular measurement, that is gradient system. What idea was behind gradient system? Instead of using 360 degree, which is actually multiple of 6, considered as multiple of 6, they decided to measure this full circle angle as 400, so that it is multiple of 100. If I divide it into 4 equal parts, one measure becomes 100. So this was the idea behind gradient system. So what they did, they considered full circle angle as 400 and the unit they selected was gradient. So in this system, what we say is that full circle angle is of 400 gradients. Instead of saying 360 degrees, now I will say 400 gradients. And then what they did, they divided into 4 equal parts to make one right angle, and they said one right angle is of measure 100 gradients, right? So the one which we are measuring as 90 degree, now I will say it is 100 gradients. Then again the problem was, what if there is an angle measure of which is lesser than 1 gradient? One right angle was 100 gradient, divided into 100 equal parts, we get 1 gradient. Now what if there is an angle which is lesser than 1 gradient? So they divided 1 gradient into 100 gradient minutes. In the previous system, what we have seen, 1 degree was divided into 60 equal parts and one part was 1 minute. Here 1 gradient was divided into 100 equal parts and one part was read as 1 gradient minute. This minute is different from the one we have studied in sexagesimal system. Then once again, if there is an angle of measure lesser than 1 minute, then what? So they divided 1 minute further into 100 equal parts and one part they said as 1 gradient second. Once again, this second is different from the second we have seen in sexagesimal system, right? So this is summary of gradient system. The full circle angle is measured as 400 gradients. So one right angle is of 100 gradient. One gradient is divided into 100 equal parts. One part is gradient minute. 1 minute was further divided into 100 equal parts. 1 minute one part was 1 radian second, right? Okay, this system is not very significant. Now moving to next system, that's the most important system of angle measurement, especially in calculus. We need this system. Okay, differentiation, integration, limits and all, everywhere we measure angle in circular system. So our next system is circular system. In circular system, angle is measured in radians. I repeat, in circular system, angle is measured in radians, which is also accepted as SI unit for measurement of plane angle. Right? So in circular system, unit for angle measurement is radian. Now let's see background story. From where does this idea comes? So idea of radian measure comes from the fact that the length of arc intercepted by angle, I'll repeat, length of arc intercepted by angle is directly proportional to measure of the angle. I'll repeat, length of arc intercepted by any angle is directly proportional to measure of the angle. I'll show it to you. Consider an angle, measure of it is suppose theta, maybe in radians or whatever. So angle measure is theta, and in this figure you can see length of the arc intercepted is S. Right? Now let's do one thing. Let's double the length of arc and see what happens to the angle. So if you see S and S, that is twice of S, length of arc is doubled, and proportionately angle is also doubled. The angle measure also gets doubled. The rotation which we are providing in order to obtain arc of double length also gets doubled. Right? So what we say is length of the arc is directly proportional to measure of the angle. So this is one idea. One more idea I'll share. If you consider an angle of whatever measure as shown in the figure, and with vertex at center, with vertex of the angle as center, if you draw arcs of different radii, intercepting the two arms of the angle, the ratio of the length of arc to the radius, corresponding radius, remains constant. So in this figure, first radius R1 and corresponding arc is S1. The ratio S1 by R1. Second radius R2 and length of arc is S2. The ratio S2 by R2. Similarly, S3 by R3. So this ratio is constant. S1 by R1 is equal to S2 by R2 is equal to S3 by R3 and so on. So what our scientists or mathematicians decided to consider this ratio. Which ratio? The ratio of length of arc, that is S by radius R. This ratio S by R to be the measure of angle. I'll repeat. So what we decided, or our mathematicians decided, to consider or to take or to accept the ratio of the length of arc intercepted by the angle and the corresponding radius as the angular measure of an angle, and that measure will be in radians. Right? So if there is an angle of theta radians, I will say measure of angle is in radians. So if there is an angle of measure theta radians, and if taking vertex as the center, if I draw an arc of some radius r, and that angle intercepts arc of length s, so theta in radians is measured as s by r, length of arc intercepted by the angle to corresponding radius. Right? So angular measure in radian is what? Ratio of length of arc intercepted by the angle to radius. Okay. So as I said, unit for angle measurement in circular system is radian. Let's check what angle measures 1 radian or what rotation measures 1 radian. So to understand that, let us draw a circle with radius r and O as the center. Consider one ray OA. Consider a ray OA with point A on the circumference of the circle. Now, mark an arc of length equal to the radius. See, as shown in the figure, measure an arc which will be, length of which will be equal to the radius. Say, the length of the arc AB is equal to radius. Join O and B. So this angle AOB we say is of measure 1 radian. Right? So 1 radian is measure of an angle which subtends an arc, of length equal to radian, equal to radius. Right? Okay. Same way, what will be 2 radians? So 2 radians is what? Length of arc if is twice the radius. Length of arc if is equal to twice the radius, then the angle measured is 2 radians. Similarly, we can draw 3 radians. So 3 radians is what? Length of arc if is 3 times the length of radius, then we say the angle is of measure 3 radians. Similarly, you can see in the figure 4 radians, 5 radians and 6 radians. Okay. So now we have an idea. What is 1 radian? 1 radian is measure of an angle which subtends an arc equal to, length of arc is equal to radius. Right? Okay. Now, let us measure straight angle. Let us measure straight angle in circular system. We know straight angle in sexagesimal system measures 180 degree. In gradient system it measures 200 gradients. Now let's check what is measure of straight angle in circular system. So to do that, let us draw a straight angle AOB with O as the vertex. Draw an arc of radius r intercepting the 2 arms of the straight angle at point A and B. So this arc is what? This arc is semicircle of radius r, right? And length of semicircle is what? Half the circumference of the corresponding circle. So length of semicircle is pi r. Length of semicircle is pi r. Now going back to the definition of angle measurement in circular system. Theta, radians or angular measure is ratio of length of arc intercepted by the angle to radius. So theta we have seen is what? S by r. So measure of this angle is length of the arc, which is actually semicircle. So pi r by radius, that is r. So you can see here r gets cancelled. So what is measure of straight angle? Pi radians. So angle, straight angle which was measured as 180 degree in sexagesimal system is pi radians in circular system, right? So in sexagesimal system, straight angle is measured as 180 degree, and in circular system, straight angle is measured as pi radian. Okay. Okay. Now let's check the conversion. So from now onwards, I know pi radian is equal to 180 degrees. Repeat. Now onwards, I know pi radian is equal to 180 degree. So what is 1 radian? 1 radian is 180 by pi degrees. Now value of pi is approximately 3.14. If you substitute that value and measure in decimals, you'll see 1 radian is approximately equal to 57.3 degrees. Not accurate, it's approximate measure. So 1 radian is approximately equal to 57.3 degree. And remember, this is an important conversion. This you will need an approximation in physics also. So one should remember 1 radian is approximately 57.3 degrees. That is approximately 57 degrees 18 minutes. 0.3 degrees 18 minutes. So 1 radian in sexagesimal system is measured as 57 degrees and 18 minutes approximately. Again, equivalence is what? 180 degrees pi radian. So let's check 1 degree makes how many radians? 1 degree makes how many radians? So 180 degree is pi radian, hence 1 degree is pi by 180 radians. If you put the value of pi as 3.14, so the value of this expression pi by 180 is approximately 0.0175. So from now onwards I'll say 1 degree is approximately equal to 0.0175 radians. Right? So 1 radian is approximately how many degrees? 57 degrees 18 minutes. And 1 degree is how many radians? Approximately 0.0175 radians. Right? Okay. Now, a common confusion among the students. Till date, we used to know pi is equal to 3.14. And from here onwards, a confusion starts. Pi is 180 or pi is 3.14. This is a common confusion. So let's see an example. We know 1 meter is equal to 100 centimeter. 1 meter is equal to 100 centimeter. Does it means 1 is equal to 100? No. This does not mean 1 is equal to 100. 1 meter is equal to 100 centimeter. The same way, here we are seeing different units of angular measure. So pi radian is equal to 180 degree. That doesn't mean pi is equal to 180. Pi, the value of pi is approximately 3.14 only. This is conversion between angles in different units. Pi radian is equal to 180 degree. That doesn't mean pi is equal to 180. Right?
No more spending your energy and money on coaching classes or missing classes for rain, for rally, and any other nonsense. Subjects covered by multiple teachers with repeat telecasts. Doubts, concepts, applications, no problem. All explained through great and significant animation. So sit back comfortably in your home and watch Study Spectrum TV channel.
Now let's see the method how to convert a degree measure, any degree measure to radian, or how to convert any radian measure to degree. So suppose you have an angle of measure theta degrees. Question is, what will be corresponding radian measure? So what we have seen is 180 degree is pi radian. So 1 degree is pi by 180 radians. So theta degrees is theta into pi by 180 radians. Unitary method. Right? So how to convert degree measure to radian measure? Multiply it with pi by 180. Just for an example, if you have an angle of measure 60 degree, question is how much it will be in radians. So multiply it with pi by 180. 63 is 180. So answer is pi by 3 radians. So angle which measures 60 degrees, now I'll say is pi by 3 radians. Right? Again, if you have an angle in radians, measured in radians, question is how to convert or how to obtain its degree measure. So pi radian is how many degrees? Pi radian is how many degrees? 180 degrees. Right? So 1 radian is 180 by pi degrees. So theta radians is theta into 180 by pi degrees. So if you want to convert radian measure to degree measure, what you need to do is you have to multiply it with 180 upon pi, right? So to convert radian measure to degree measure, we'll multiply by 180 by pi, and to convert degree measure to radian measure, we'll multiply it with pi by 180. Okay. Now, little uses of board and some problem solvings will help you understand this concept better. So I'll move to board. So students, I have written few angles, measurement of some angles in degrees, minutes, and then in radians. Let's see how to find the measure of these angles. If it's given in degrees, how to find its radian measure, or if it is given in radians, how to find its degree measure. So the very first question I have written here is 315 degrees. What I want is to convert this to radian measure, or I want to find 315 degree is how many radians. So we have just discussed, if you want to convert degree measure to radian measure, what we'll do is we'll multiply by pi by 180. So I'll say 315 degree is 315 into pi by 180 radian, right? So if you want to convert degree measure to radian, what we need to do is multiply by pi by 180. So 315 degree is 315 into pi by 180 radians. Let's simplify it further. 45 fours are 45 sevens are. So answer is 7 pi by 4 radian. So 315 degree is 7 pi by 4 radians. Okay. Moving to next. Suppose I have 43.5 degree. Here degree measure is 43.5 degrees. Question is, what will be value of 43.5 degree in radians, or what will be radian measure of this angle? So again, multiply 43.5 by pi by 180. So this is the answer in radians, right? Now if you want to simplify, 15 is 12 and put a 0 as if I divide by 1.5. 15 if you divide 2 and then 9. So answer is 29 pi by 120 radians. So 43.5 degrees is 29 pi by 120 radians. So what I have done here is 43.5 I have multiplied by pi by 180 and then simplified it. 1.5 I have divided 43.5 by 1.5, the result is 29, and this I divide by 1.5, so result is 120. So answer is 29 pi by 120 radians, right? Okay. Now moving to next. Question is, what is radian measure of minus 30 degrees 30 minutes? Minus 30 degrees 30 minutes. So first of all, so we have degree conversion to radians, but here we have a measurement in minutes. So first I'll convert this to degrees. 30 minutes, 60 minutes makes 1 degree. So 30 minutes is 0.5 degree. So this is nothing but minus 30.5 degree. Minus 30.5 degree. Now I'll convert this to radians. And how to do that? Multiply it with pi by 180. So answer would be minus 30.5 into pi by 180 radians, right? Simplify it further if you want. 180 divided by 5 is 36. If I divide by 0.5 it would be 360. Divide this by this, so 61. If I divide by 0.5 instead of 5. So answer is minus 61 by 360 pi radians. So minus 30 degrees 30 minutes is nothing but minus 61 by 360 pi radians. Okay. Now let's see. Here we have radian measure. There is an angle radian measure of which is pi by 4 radians. Radian measure of which is pi by 4. Now question is how to find its degree measure. How to convert this radian measure to degree measure. So we have seen earlier, if you want to convert radian measure to degree measure, what we need to do is we have to multiply it with 180 by pi. So I'll say pi by 4 radian is pi by 4 into 180 by pi degrees. Pi gets cancelled, 4, this is 45. So answer is 45 degrees. So pi by 4 radian is 45 degrees. Right? Okay, next one. Again we have a radian measure of an angle, and that is 5 pi by 6. That's an angle, radian measure of which is 5 pi by 6. Question is how to convert into degrees, how to obtain corresponding degree measure. So what I'll do is I'll multiply once again this with 180 by pi to obtain degree measure. Pi gets cancelled, 6, this is 30, 35 is a 150. So degree measure of angle 5 pi by 6 radian is 150 degrees. Right? Okay. Moving to next. 4 radians. 4 radians. By now you would have developed the thing if this is mentioned, the symbol superscript 0, then we say it is degree measure, and if the C is written, then it's radian measure. But mostly radian measure of angles we deal in is expressed as pi by 4, pi by 6, pi by 3, pi by 2, 5 pi by 6, 7 pi by 2. And students make a concept, if angle is written in terms of pi, then it must be a radian measure, and if it is written in numbers, then it must be a degree measure. But that is wrong. In fact, in calculus, while dealing in calculus or say even in physics and other, if superscript is not given, just 4 is written, by default it is radian measure. By default it is radian measure. So even if 4 degrees written, so I know it is a degree measure. If 4 and C is the superscript, I know it is a radian measure. If nothing is written, then also it is radian measure. So in calculus and other topics, by default, if nothing is mentioned, we understand that it is, or we consider it as a radian measure. So 4 radian is possible. In fact, 1 radian we have seen earlier. 1 radian is approximately 57.3 degrees. So 1 degree is there, 1 radian is also there. 1 radian is equivalent to 50 or equal to 57.3 degree approximately. So here we have a radian measure of an angle, and that is 4 radian. Question is what will be degree measure of this? So 4 radian is equal to 4 into 180 by pi degrees. 4 into 180 by pi degrees. If you consider the approximate value of pi, that is 3.14, we can simplify it to approximately 229.09 degree. I'll repeat, if you consider this value pi to be 3.14, then this value is approximated as 229.09 degree. Right? Again, this is not accurate value, this is approximate value of 4 radians. So 4 radians is approximately 229.09 degree. Right? Okay. Suppose I want to convert this fractional part into minutes. So what I'll do is I'll multiply 0.09 by 60. So what do I get? 229 degree 5.4 minutes. 1 degree is 60 minutes. So 0.09 degrees 5.4 minutes. Again, this fractional part, if you want to convert to seconds, so this 5 minutes and 0.4 minutes are there, fractional part. I'll multiply it with 60 so that I get 24 seconds. So degree, minutes and seconds in 4 radians is 229 degree. Again, approximately 229 degrees, 5 minutes and 24 seconds. Right? So this is approximate value of 4 radians in degrees, minutes and seconds. Clear? Okay. Now, let me state a problem. Suppose there is a right angle triangle. Suppose there is a right angle triangle and degree measure of one of the acute angles is 60 degree. Degree measure of one of the acute angles is 60 degree. Question is, what is measure of second acute angle? So for reference, let me name a triangle ABC, which is right angle at B. Angle A measures 60 degree. Question is, what is measure of angle C in radians? Right? So this is what we have to find, and that too in radians. So what we can do is, we'll find degree measure of this and then we'll convert it to radians. This is right angle, so it measures 90 degree. And angle C is what we have to find. Now, we know very well, sum of the 3 interior angles of a triangle is 180 degree. So angle C plus 60 degree plus 90 degree is 180 degrees. 6C plus 60 degree plus 90 degree is 180. 60 plus 90 is 150. Take it on that side. 180 degree minus 150 is 30 degrees. So degree measure of angle C, is 30 degrees. Right? Then question is, what will be radian measure? So what I'll do is, I'll multiply this with pi by 180. Gets cancelled 6. So radian measure of the angle C is pi by 6 radian. Right? I'll repeat. Radian measure of angle C is pi by 6 radians. Okay. Now, moving to one more question. Question is, find measure of interior angles of regular octagon in radians. I'll repeat. Question says, find measure of interior angles of a regular octagon in radians. So, I'll start with sum of all the interior angles of any regular polygon. I'll start with this. Sum of all interior angles of a polygon is given by formula n minus 2 into 180 degrees or n minus 2 into pi radians. In fact, this is very interesting. I'll draw a figure here and I'll show you how. This thing is based on the fact that sum of all interior angles of a triangle is 180. How? Suppose there is a triangle. How many sides are there? 3 sides. Sum of all these 3 angles is 180 degree, whatever be the type of the triangle. Now let's take quadrilateral. Suppose I want to find sum of measure of all interior angles of a quadrilateral. What I can do is, I can divide this quadrilateral into 2 triangles. So this plus this plus this plus this is same as this plus this plus this, this plus this plus this. Right? And sum of these 3 is 180 degree, sum of these 3 is 180 degree. So how many sides were there? 4 sides. So how many triangles are formed? 4 minus 2, that is 2 triangles. So answer would be 4 minus 2 into 180. That is 2 into 180, 360 degree. And if extend this, suppose it's a pentagon. In pentagon, in a similar manner, we can draw 3 triangles. If I consider a little space of left, say if I consider this as, this is quadrilateral. if you consider a pentagon. So how many triangles are formed? 3. 5 sides, 2 sides are gone, 3 triangles are formed. So answer would be 5 minus 2 into 180. Right? So general formula is sum of all interior angles of a polygon is n minus 2 into 180 in degrees. So n minus 2 into pi radians. Right? Therefore, the polygon given to us is octagon. Therefore, sum of all interior angles of an octagon. Octagon has how many sides? 8 sides. 8 minus 2 pi. 8 minus 2 pi. That is 6 pi radians. Remember, if nothing is written, then it is understood it is radian measure. Right? So 6 pi radian is what? Sum of all interior angles of a octagon. Now, octagon used here is regular octagon. And what does this word regular means? Regular means all the sides are equal and all the interior angles are equal and all the exterior angles are equal. Right? So, octagon regular means what? All the angles are equal. And now, how many angles, interior angles are formed within an octagon? 8. 8 sides and 8 angles. Therefore, measure of each angle, interior angle remember, is 6 pi by 8 radians. That is 3 pi by 4 radians. So that's your answer. So measure of interior angles of a regular octagon in radians is 3 pi by 4 radians. Right?